Hello, ladies and gentlemen. This is the third international conference on ICT for Development Africa, and the conference paper titles on investigate risk factors and predict neonatal infant mortality based on maternal determinants using homogeneous sample methods. And when it comes to introductory parts, as we know, healthcare is one of a major global concern, especially nowadays. Uh, and also it indicates the quality of life of one's country, and it also increase the gross domestic product of one's country. And although from this health care from different healthcare issues, mortality remains one of the global concern. uh, like we can take a COVID-19 or child mortality and different maternal mortality, and we can take different same examples. And from this, as we are living in a developing country, especially in Africa, most of mortalities are occurred in during a child. So uh, a child mortality is refers to the mortality of a children of under 5, uh, which is a main health issue through the world. And according to WHO, or World Health Organization, about 6 million children die before reaching their 5th birthday across the world. And if this current trend continue between 2070 and 2030, more than 60 million children uh, under the age of 5 will be die from this. Now, from this, 3 million deaths are occurred within 28 days of the birth. Uh, and from these 3 million deaths, 98% of neonatal deaths are occurred in developing regions like Southeast Asia and sub-Saharan countries. And also, Ethiopia is one of the sub-Saharan countries which is affected by a preventable and treatable cause of a child mortality. Um, Most of the uh, mortality in developing countries are occurred due to the preventable and treatable causes. So, and according to Ethiopian Mini Demographic and Health Survey 2019, a child mortality rate 43 of 43 of the from 1,000 children are uh, died due to this preventable and treatable cause. And to prevent this child mortality or neonatal infant mortality, this is important to set the early prediction and discovery of risk factors. And this may be essential for saving a children and evaluating effectiveness of setting interventions or a policy making task. So, to this end, uh, the previous researchers were implemented different statistical data mining and machine learning algorithms uh, to prevent a neonatal infant mortality. However, they didn't consider the maternal data. So, to prevent a neonatal mortality, we have to consider the maternal data, because being a neonatal by itself, which is not a disease, so we have to know the background of a maternal background of a mother uh, during a pregnancy, before a pregnancy, and after a pregnancy. So we consider the maternal data, and with this lack of sample methods, uh, the previous researchers didn't consider the sample methods. They only used the individual machine learning algorithms or data mining algorithms. So, since the aim of This study is to prevent neonatal infant mortality in Ethiopia based on a maternal data using homogeneous and assembled machine learning methods by investigating the following research questions. These are: first one is, what are the maternal factors affecting neonatal and infant mortality in Ethiopia over the course of 16 years? And which sample model is optimal for predicting neonatal infant mortality? And what are the most relevant rules that helps to formulate a neonatal and infant mortality prevention and controlling policy? And to answer these research questions, we develop a predictive model by using this materials and methods. Before developing a predictive models, we have to pre-process the data, and the data is comes from Ethiopian Demographic and Health Survey with 2000, 2005, and 2011 and 2016 data, and we integrate this data. After integration, handling inconsistent data. From this data, the different features have inconsistent data, like a type of toilet facility and the general region of residences. And also handling missing values. Missing values are handled using different methods based on the properties of the features. The first one, ignoring the tuple. When we get the missing values in a class level or target variable, when we get a lot of missing values in a class level, we have to ignore it. When we feel and using it for a prediction, it may be indicate the wrong prediction or the wrong output. And we use the conditional imputation methods. Based on one attribute, we can fill the another attribute. The age at days is fill based on a child alive base. When a child is alive, age at days is missing, so we fill the age at days missing using a child alive based data. So we use a conditional imputation method, and also mean imputation method for the features or the attributes which have a numerical data type, and mode imputation method for a categorical data type features. And the another pre-processing part is binning or data transformation. From binning, preceding birth interval, age at days, maternal age, and number of tetanus injection before birth, time of first antenatal check. These are binned based on different recommendations from WHO or World Health Organization. And so the data is not balanced, which is up to, as we see from the graph, the data is not balanced, which is 1:9 ratio. So we have to balance it by using smooth. We were balance it using smooth technique. And to develop a predictive model, we have to, before developing a predictive model, we have to train the data, and then finally we have to test. So for a train test split, we use 80 by 20 training test split using a stratified k-fold random subsampling method. And also some features are selected using the random forest feature importance method, and from this we get some features preceding birth interval, preceding birth interval and delivery matter and so on. And when it comes to experiment and results, we answer the the research questions. And what are the maternal factors affecting neonatal and infant mortality in Ethiopia over the course of 60 years? These are preceding birth interval, current breastfeeding, family plan use, a number of tetanus injection before birth, educational level, and frequency of listening radio, also a place of delivery. These are the factors which is affecting the neonatal infant mortality over 16 years in Ethiopia. And which sample model is optimal for predicting neonatal and infant mortality? As we know, rather than the individual models, using individual models, sample models can increase the performance of the models. And also in this, as we see from this table, the sample method does increase and the base accuracy from 85, which is from 85% to 87% by bagging and AdaBoost. And bagging and AdaBoost enhances the decision tree classifiers from 91.75% to 94% using the bagging, and AdaBoost also increase the individual algorithm decision tree by 94%. So the AdaBoost, rather than a bagging, AdaBoost can perform the best or the optimal prediction performance for neonatal and infant mortality in Ethiopia, because AdaBoost is done by using a sequential way rather than bagging. And also the sample methods are used for decreasing the bias and variances. So the third one is, what are the most relevant rules which are used for the interventions, the prevention interventions and the policy making tasks? Those are some rules which are given from this experiments. These rules are extracted by using AdaBoost, because we will get the best performing algorithm by AdaBoost. That's why. And a simple method maximizes the performance of individual classifiers by 4%, and AdaBoost with decision tree registers the high accuracy and ROC in predicting neonatal infant mortality. And finally, this finding suggests that neonatal and infant mortality is highly associated with maternal and maternal-related factors, which are vaccination and family planning, like birth spacing and use of contraceptive methods. So, to prevent and control neonatal and infant mortality in Ethiopia, stakeholders must formulate policies and interventions, which is based on by taking into account the maternal and maternal determinant factors for neonatal and infant mortality. And so, finally, the future researchers may use the application of hereditary sample methods to enhance the performance of a prediction models. Thank you. If you have a question, welcome.